remember things better?
Here we go.
All right, let's look at ionic bonds. Ionic bonds are not the same as covalent bonds. They are different, except there are some similarities. They also involve valence electrons, and they also involve bonding atoms together. So let's look at ionic bonds. Ionic bonds are formed when atoms transfer electrons. Now we are not sharing anymore. We are now transferring the electrons. This means they're either gaining or they're losing electrons. And one other thing that didn't get included on your notes here that I want you to add, we're going to put it over here in the corner. One thing that's really cool about ionic bonds is an ionic bond will only occur between an atom that's a metal and another atom that's a non-metal. So ionic bonds won't happen between two nonmetals, and they won't happen between two metals. One has to be a metal, and one has to be a non-metal. And we'll look at that as we look at our two examples. Another thing is you'll notice that ionic bond sounds a lot like a word we had in the previous unit, ion. And one of the reasons for that is because ions are actually formed as a part of the ionic bond process. So here we go.
Oh, yeah.
Okay. An atom or molecule in which the total number of electrons, this is a review, definition of ions, is not equal to the total number of, what kind of charge do protons have? Positive protons. So we've got positive protons and negative electrons. If they are out of balance, what happens to that atom?
It's unstable? No, that's
the neutrons. Unstable is neutrons. Now instead we get a charge. Page. Negative or positive. Very good. Yeah. Giving it either a negative or positive electrical charge. Oops. So let's take a look at what transferring electrons between nonmetals and metals looks like. And we're going to start off simple with a really important compound, NaCl, which is what, everybody? Salt or sodium chloride. So I'm going to use black for my sodium and green for my chlorine. You pick two colors that you want to use for them. Okay. I'm going to put sodium on this side. And I'm going to do chlorine on this side. All right. So here we go. First of all, we said these only happen between metals and nonmetals. So let's take a look. Sodium, and you might not be able to see, but up here on our periodic table, notice sodium is in our first group on the left-hand side of the periodic table. So is it a metal or a non-metal? Let's go back to last unit. It's a metal. Very good. Sodium is a metal. And now look on your front page. What's in the happy box? What does sodium need to be happy or to gain or lose? Micah?
Well, for sodium, it needs, since it has 1 valence electrons, it would need 7 more.
No, we don't. Getting 7 would be really hard.
Oh,
It would be a lot easier to
take one away.
So it wants to lose 1 electron. All right, let's look over here at chlorine. Chlorine's over here. Anybody remember what this group is? Second one from the end. Zoe?
halogen.
Very good. It's a halogen. And chlorine, metal or non-metal? It's over on the right-hand side. It's a non-metal. Good. And what's in chlorine's happy box? Mitchell?
+1.
Okay. It wants to gain 1 electron. Okay. Do we see something going on here?
Yeah.
Okay. This one wants to lose 1. This one wants to gain 1. So let's see what this looks like. Let's draw a sodium atom. By the way, how many sodium atoms am I going to need to draw? 1. Okay, so let's draw 1. Sodium has 11 electrons. So we're going to draw our Bohr model here. On the first electron shell, how many do they go? 2. Our next electron shell? 8. And we've got 1 left over. So that poor little 1 goes out in that outer shell, and that's our valence electron. Now we need to do our chlorine. How many chlorine atoms are we going to need to draw?
17.
That's how many electrons.
Oh.
Sorry about it. Here we go. Come on.
1.
Chlorine atoms, 1, right? Look at our compound formula. It says that we need to just draw 1. But that 1 chlorine atom is going to have how many electrons, my guy? 17. There we go. Bringing it back. All right, so here we go. 17. It's okay, Micah. You're not the first student to do that to me today. I was like, 17. Okay. That makes me feel better. 8. And then how many on the outside, Sarah? We need a total of 17. We've got 10 on the first 2. 7. Yeah. Good job. Okay. So there we have our chlorine, there we have our sodium. Remember, neither of them are happy, neither of them are meeting the octet rule. And so we're going to form an ionic bond so that they can meet their octet rule. So instead of sharing like in covalent bonds, now what's going to happen is this little extra electron here is going to get transferred to the chlorine atom. Transfer. Excuse me, sir, you have been transferred to a new job. Okay. Kicking you out. All right. And now, that sodium electron goes over here and joins the chlorine. And because of that, our sodium now becomes an ion. What kind of ion is it, Lillian? Sodium.
Sodium become a positive one because it lost an electron.
Awesome. Yes, it's a positive electron. A positive electron. No, it's a positive ion because it lost an electron. And now, because it's an ion, we have to write it a new way. Guess how we have to write it? We have to give it a superscript.
Oh, that's what was on the homework.
So now it gets a plus sign because it's a positive ion.
Oh, that's what that was in the homework.
Uh-huh. Yes, putting it together. Putting it together. So let's look at chlorine. Chlorine gains an electron, so now it has what charge, Elizabeth? It gained an electron. It got an extra electron. Electrons are negative, so now it has a negative charge. Okay, so now chlorine is a negative ion. So now we have to write chlorine a different way. So now we also give it a superscript. But instead of it being positive, it has a negative. And so now our chlorine is negative, and our sodium is positive, and ladies and gentlemen, opposites attract, right? So an ionic bond is going to form, and these two come together, boom, boom, and they become NaCl. How many bonds did we make there? How many bonds? Just 1. Yep, just 1. Good. Ready to try it again?
Yay.
Or should I pause? Questions? Okay, we're going to try it again. This time we're going to do it with magnesium chloride. Magnesium chloride. I'm going to be using blue and green. I'm going to use green again for chlorine. I'm going to use blue for magnesium. You pick your colors. Lillian.
Would it be easier for magnesium to bond with oxygen?
It does sometimes, yeah.
What does that mean?
Magnesium oxide.
Which is, does it have a common name?
No, I know. Magnesium chloride, you can find this if you ever, it's something your bodies need. You can ingest this. But often people will use this. It's another type of salt that's used in the bath salts. So if you ever take like a bath, it'll be in that. Okay. Anyways. So magnesium chloride here. I'm going to do my magnesium, like I said, in blue. I'm going to put magnesium over here. Put my chlorine over here. Okay. Let's look at magnesium. Is magnesium a metal or a non-metal? Metal. It's a metal. What's in magnesium's happy box? What's it need to be happy?
Needs to get rid of 2 electrons.
Yep, it wants to get rid of 2 electrons. Chlorine, we already did up above, so we already know it is a nonmetal. And we know to make it happy, it really wants 1 electron. All right, how many magnesium atoms do we need to draw? How many atoms? Yeah? 1, right? Because look at our compound formula, 1. We're also going to need to draw chlorine atoms. Andre, how many chlorine atoms do we need to draw?
Wait.
Chlorine atoms. Look at your compound formula. How many needs to tell you?
Oh, 2.
2. Very good. Okay. So we're going to draw 1 magnesium and 2 chlorine. So here we go. Pick your colors. Magnesium has 12 electrons. And you can tell, you can look up above and know that chlorine has 17. You're drawing them again. Here go my chlorines. My circles need some help. Here we go. Remember to obey your energy levels. Only 2 on the first one, 8 on the next one, and whatever you have left over on the third. Can you see what's going to happen? What's going to happen? It's okay. Look at these 2 extra ones. Remember, magnesium wants to get rid of 2. So they're going to leave. Here we go. This one's going to go over here to this chlorine. This one's going to go over here to this chlorine. They're both going to get transferred, not shared, transferred. And they're going to join the chlorine atoms. After that has happened, is magnesium happy?
Yes.
Yes. How about our chlorines? How are they feeling?
Happy.
Happy. They've got their 8. They've got their octet, right? Now, magnesium, once those electrons have been transferred, has what kind of charge on it? Positive. So we can't write magnesium the same way anymore. Now we need to write it with a plus sign. But not only do we need to write it with a plus sign, now because it's not only gotten rid of 1 electron, it's gotten rid of 2 electrons. So we write plus 2. Over here we've got 2 chlorines. The chlorines have now become what kind of charge? Negative. So now we have to write them differently as well, because now they're ions, and they have a negative charge. They've only each gotten 1, so we can just put the negative sign. We don't need to write the 1. Negative, negative. Now they've become ions, and voila, we end up with magnesium chloride. How many bonds do we have to make magnesium chloride, Paige? 2 bonds. Very good. 2 bonds. And just like that, 2 ionic bonds have formed. You can turn it off so
Okay.